Okay, so this is the ideal gas law page. First of all, I'm just going to let you know I'm not going to be doing like half of them because they're just way too advanced for what we're going to need to know. I'm just going to do maybe the first four because that really just goes through the actual formula. So first of all, the formula is here. PV equals nRT, where P equals pressures. Now this says in atmospheres. We could have it in kilopascal as well, but the reason why it tells us atmosphere here is because it uses this value for R. Remember, if you used kilopascal, you'd use the 8.31 value for R, but this sheet is using atmosphere, so that's good enough. V is volume in liters, N is number of moles of gas, the R is that constant, which by the way is on honors reference table A. T has to be in Kelvin because it's absolute scale. So the first thing I did was I went through, because this sheet was a pain, and it gave me all the temperatures in degrees Celsius, so I had to change those to Kelvin. It gave me pressures in torr, so I had to make those atmospheres, and we'll take care of 3 and 4 in a moment, but let's just go to the beginning here. How many moles of oxygen will occupy a volume of 2.5 liters at 1.2 atmospheres and 298 Kelvin? So PV equals nRT. We're looking for moles. So 1.2 times 2.5 equals, I don't know, 0.0821 and 298. Okay? Pressure, volume, moles, R, temperature. Okay, so 1.2 times 2.3, 2.76 equals 0.0821 times 298 is 24.4658 times N. So divide both sides by this 24 business. So 2.76 divided by 24.4658 is 112 moles. Okay, now sig figs. Looks like 2 sig figs, so I guess 0.11 would be fine. Let's not worry about sig figs. Okay, but that's basically, the formula is not very hard. Let's try the next one. What volume will 2 moles of nitrogen occupy at 0.947 atmospheres and 293 Kelvin? So I had to convert to have all of our units correct. So we're looking for volume. So P V is what I don't know. And N R T. So calculate 2 times 0.0821 times 293, 48.1106 equals the quantity 0.947 times V. So divide both sides by 0.947. 50.803, etc. And let's talk sig figs. Looks like 2 sig figs here. So that should be 51 liters. Okay, now 3 and 4 was even trickier because they didn't give us moles, they gave us grams. So we had to convert from grams to moles in addition to all those other conversions. Because, you couldn't just do some algebra here. So it says, what pressure will be exerted by 25 grams of O2? So we divided by 44, which is the GFM, and we got our moles, 0.568. And then temperature, and now I have a volume that's not in liters. It has to be liters, so I did that. So P is what I don't know. V equals N T. Okay, so let's see. We have 0.568 times 0.0821 times 298 gives you 13.896 whatever. And we're going to divide it by 0.5. We're going to get, so divided by 0.5. We're going to get 27.79, etc. Looks like 2 sig figs though, so 28. And the pressure, so that's atmospheres. Wow, that's a lot. And number 4 is the last one I'm going to do. So temperature this time. Once again, they made me convert to moles and atmospheres and liters. So P is 1.18 pressure. V is 0.750. N is 0.0714. R is 0.0821 and T. So 1.18 times 0.750 is, this is so messy here, I apologize, 885 equals 0.0714 times 0.0821 is really small, 0.0586 times T. So divide both sides by 0.0586, 0.0586. So now I got to go back here. 0.885 divided by 0.00586, 151.02, etc. So yeah, we'll go with 151 Kelvin. The answer key that I have says 154 Kelvin. I think this is where the issue is. Chlorine has a molar mass of 35.5. I just kept it 34.5. I just kept it at 35. And I think that's where the rounding issue came in. But really, 151, 154, it's pretty darn close. Like I said, the rest, we could definitely get into it, but this is not a Regents topic anymore. If you understand PV equals nRT, understanding why the units have to be consistent, this is good enough. So, all right, thanks.